Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss conductance of electrolytic solution. Conductance of electrolytic solutions. Last class I have discussed electrochemical cell and Gibbs free energy of the reaction. Means I have derived delta G is equal to minus NFE. Now I am going to discuss conductivity of or conductance, you can tell, conductance of electrolytic solution. Here before going in depth of this conductance of electrolytic solution, we should know some terms. Okay, it is necessary to define a few terms before we consider the subject of conductance of electricity through electrolytic solution. Means here that current passes through the metallic wire like a copper, aluminum, silver, current passes. But here you should know that in chemistry, in physics you are studying that current is passing through the wire, maybe of silver, maybe of copper, maybe of aluminum. But here in chemistry you will study current passes through solution also. Means solution also conducts electricity. Why and how? Then here actually the definition that flow of electron is called current. First definition. Second definition, flow of charge is also called current. This is the important things here. Flow of charges, maybe cation, anion, then flow of charges in solution is also called current. Then here you will study these things. In electrochemistry, here you will study that things only, flow of charge. Then here you know that in solution, in solvent, if you will add solute, then it becomes solution. Now salt will dissociate into ions, cation and anion. Then when I can say electrodes, if you will introduce the electrode and through it if current will be passed, if you can say this will be passed voltage, then what you will see that ions will move to opposite charge, means positive ion, that is called cation, it will move to the negative electrode, and negative ion, that is called anion, it will move to the positive electrode. Correct? This means it will conduct electricity, current will be pass. This you know. Then this ion moves. What I want to tell you that this ion carries charge, either positive or negative. Correct? Then this, if it carries positive charge, then that is called cation. If it carries negative charge, it is called anion. That is actually charge carrier. It carries the charge. Just like you can tell, truck carries cement, sand, bars, many things it carries. Correct? This is also carrier. Here ions are charge carrier. They carry the charge. Then here some terms you have to understand. Then first term that you have to understand, that is the resistance. Resistance. What is the actually this resistance and how it is related? How resistance is related to the conductance? Now I am telling you. The electrical resistance. The electrical resistance is represented in the symbol, that is a capital R. The electrical resistance is represented by the symbol R, capital R, and it is measured in ohm, OHM, in the name of scientist, ohm. Okay, which in term of SI unit. In SI unit, it will be, its a unit is equal to, its unit is equal to the meter square per Simon square. Meter square per Simon Q, per Simon Q you can tell, Q and A square. It can be measured with the help of Wheatstone bridge, with which you are knowing actually Wheatstone bridge, it is in physics also, that by Wheatstone bridge you can determine the resistance. Okay, then resistance is represented by R, and in SI unit, that is the base unit, this is called base unit. This R is equal to this thing, kg meter square, kg meter square divided by SQ A square. Okay, and here mathematically, here actually you should know that what is the in these things, A square, the electrical resistance of any object. The electrical resistance of any object is directly proportional to the length and inversely proportional to the you can say cross section. Okay, then here R is equal to L, means it is a proportional actually. R is directly proportional to L upon A. L upon A. Then electrical resistance means R is directly proportional to L and inversely proportional to A. What is the A here? A is the cross section. A is the cross section. Then now here for a base unit of resistance, I have told you that kg meter square divided by SQ A square. Then here all things are knowing. Kg is mass, meter is square, that is a meter is a length, divided by Simon Q. S, this is a new term, Simon. Okay, I will tell you about this in details, that I will discuss. SQ, okay, divided by SQ A square. A square is the cross section. Okay, cross section of the these things, conductor, any conductor. Then electrical resistance of any object is directly proportional to the length and is inversely proportional to its area of cross section. A means area of cross section. Okay, then here S, it is a new. It means Simon, and Simon is the you can say SI unit of conductance. SI unit of conductance, that is the Simon S. Then now this unit, simple unit of resistance is ohm. Okay, OHM, ohm. And this in terms of SI base unit, it is equal to the kg meter square divided by Simon Q A square. Then now I have told you R is directly proportional to length and inversely proportional to A, capital A. Means R is directly proportional L upon A. Then now if you will remove the L is the length of the conductor or wire, you can tell length, and our solution you can length of solution. Here wire you can't tell because you are talking about the solution. Then length of solution, cross sectional area of solution. Okay, then L into L, that is the length, and the cross section area. The area into length. You know, area into length it is volume, because in area length and breadth is related. Length, breadth, height, that is the V. Then area means volume. In volume you multiply by length. 3, length, breadth, height. Correct? If you multiply 3, you will get volume. Then here cross section area, A, capital A, that is the area. Then if you multiply L, then it will called volume also. Okay, I will discuss this concept later on. Then now here R is directly proportional to L upon A, and a small l you can tell, a small l divided by capital A. Then if you equate it, if you convert into similarity, then R is equal to 1 proportionality constant. You have to multiply by 1 proportionality constant, that is the rho, just like a small p type rho, RHO, rho. Then now R is equal to rho into L upon A. Then what is this rho? Then this rho actually is a proportionality constant and is called resistivity. Resistivity means a specific resistance. Resistivity means a specific resistance. Then now actually this specific resistance term, now according to IUPAC, now it is known as resistivity. Now this term is known as resistivity. Now this specific resist term is nowadays it is not used. In its place earlier it was used. Now it is known as resistivity. In SI units, or you can say it's a SI units are ohm meter. What is actually resistivity? Then its unit is ohm meter. Okay, and actually ohm, this symbol is there. How will you represent ohm? In the form of symbol. Then just like you can tell 1 is 0, but down you think some place is open, or better you can understand, just what you can tell that now that is actually you can understand like that one symbol structure is there, that just like you can say glass you will reverse. Glass you will keep in a reverse way, down it will be opened everywhere it is covered. But here it is a think it is not in the form of glass, it is just like a sphere, but down it is opened. Down it is colors, colors, that colors reverse it, then down will be opened. That type of symbol is there. Okay, means spherical, but down it is little opened, little opened, just like a colors. Okay, you are keeping like that way, symbol is there. Then this resistivity rho is called resistivity. Okay, and one thing I want to tell you that how will you define. I will tell one relation, after that again I will come to this term, that this actually I told you ohm meter, its unit is ohm meter, or in these things, in other term also you can tell these things, ohm centimeter also you can tell, ohm meter or ohm centimeter. Okay, this is generally it is used ohm meter or ohm centimeter. Okay, it is used as a ohm centimeter, or but SI unit is ohm meter, CGS unit is ohm centimeter. Okay, and how actually resistivity is related. Resistivity for a substance is the resistance. It is actually resistance. Everything resists. Just like you are, suppose you are just driving motor, these things, cycle, bicycle. Okay, and someone is pulling. You are bicycle you are driving, and someone is, you can say, pulling. Then what will be the speed? Speed will be less. You will face more problem due to that pulling. Some person is pulling and you are driving. Then this is just like a resistance. It is protesting. Then like that way, resistance meaning is like that, protest. They are against, that is a force which is working against. Force working against, correct, against the main work. Okay, just like if a road is a smooth, pitch road, then like a national highway, then you can drive motorcycle very fast. But if road is not good, just like some concretes are there, then your speed will be less, motorcycle speed will be less. Then that is the meaning of resistance. Then I told you resistivity means resistance. Okay, for a substance, resistivity for a substance is the resistance when it is 1 meter long and its area of cross section is 1 meter square. Keep in mind. Okay, the resistance when it is 1 meter long. Okay, resistivity for a substance is the resistance when it is 1 meter long and its area of cross section is 1 meter square. Correct? This is actually resistance. Resistance of what? Now you are understanding? It is resistance of 1 meter long and its area of cross section is 1 meter square. Then 1 ohm meter, if you want to tell in the term of centimeter, then 1 ohm meter is equal to 100 ohm centimeter. 1 ohm meter is equal to 100 ohm centimeter. Then 1 ohm centimeter in terms of meter, that is the 0.01 ohm meter, because 1 is equal to 1 ohm meter is equal to 100 ohm centimeter. Then 1 ohm centimeter means what? 1 divided by 100 means 0.01 ohm meter. Then this is the relation. Then now come to the other point, that is the actually this what is the conductance? What is actually conductance? Then now you have to understand the inverse of resistance. The inverse of resistance is called conductance, means 1 upon R. R is the resistivity or resistance, you can tell. Then 1 upon R, that is called conductance, G. It is represented by capital G. Okay, resistance, capital G, means capital G is equal to 1 upon R. And now here you put the value of R. You know the R value. R is equal to rho into L upon A. Correct? I have discussed. R is equal to rho into L upon A, because R was proportional. R is proportional to L upon A. Then now you have changed the proportionality signs to equality signs. Equality. Then you have multiplied by a constant. That constant, proportionality constant, is known as resistivity. Correct? Then R is equal to, R is equal to rho into L upon A. Then this value put here, G, capital G, means conductance is equal to 1 upon R. Conductance is equal to 1 upon R. If you will put the value of R, then means rho into L upon A, then what will happen? That here A will go upside and rho and L will be down. Rho and L will be down, means G is equal to A upon rho L. Rho into L. A is upside, numerator and denominator, rho into L. Then now here one more things again you have to know, you should know, that now G is equal to L upon R, G is equal to 1 upon R, inversely proportional, inversely related, not proportional. The inverse of resistance, G is equal to G, conductance. Then G is equal to 1 upon R, and you have put the value of R, then now it became capital A divided by rho into L. Rho is down. Then now new things here I am telling you, that rho is down. Then 1 upon rho, that is called kappa, a small, just like a small k, kappa. And this is actually called conductance. Means 1 upon rho, I will tell you, that is actually called conductivity. Conductance and conductivity both are different. Okay, conductance, now you are knowing 1 upon R, and R value you have put, then now it became, that is equal to A divided by rho into L. Then 1 upon rho, that is called kappa, and kappa means conductivity. Actually earlier it was known as a specific conductivity. Okay, that also now according to UPSC, that is called as a conductivity. Okay, but earlier it was a specific conductance. Then two conductance was coming earlier, conductance and specific conductance. Then this 1 upon rho or 1 upon resistivity, that was called that time a specific conductance. But for the specific conductance, now term is changed by conductivity. Hence conductance and conductivity has different. Okay, different. Then SI unit of conductance. SI unit of conductance is Simon. Okay, standard international unit, international system unit of conductance is Simon, and is represented by the symbol S, capital S. In the beginning, SQ, I have used the term that S. Okay, that S. Then this is the Simon, and is equal to per ohm, ohm minus 1, ohm power minus 1, also known as MHO, because OHM minus 1 is there. Then you can write MHO also, mho, 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 like that you can tell. Ohm, OHM, power minus 1, inverse. Then you can write MHO also. Okay, or mu inverse, or ohm inverse, or also you can write, symbol is there, symbol sign of ohm minus 1. Then this is actually conductance, correct? Simon is the unit of conductance, represented by the symbol S, and is equal to ohm inverse. Don't forget ohm inverse, that also you can write MHO, and in the term of symbol ohm minus 1, ohm inverse. Okay, now another things already told now about the rho, kappa, about the kappa. The inverse of resistivity, that is called conductivity. Means rho, you are talking about the rho, 1 upon rho. The inverse of resistivity is called conductivity. Earlier it was called a specific conductance. But now, according to Upsc, it is known as this thing, conductivity. In the earlier it was known as a specific conductance. Conductance and a specific conductance. 2 times conductance we were using, conductance and a specific conductance. Now it became conductance and a specific conductivity. And this specific conductivity actually is known as kappa, a small k, Greek word kappa. Okay. Then now these things I told about the term conductivity. Okay, now this term only, conductivity, is used in the place of a specific conductance. The SI unit of conductivity are here because conductance is a Simon, S, Simon. Then here what will be the unit of conductivity? Then here you have to add extra one things, per meter. Because if conductance you are measuring, then length must be considered length, then per meter. Then S small m minus 1, Simon per meter, that is the unit of conductivity. Question is asked. The SI units of conductivity are, you can say, S per meter. But quite often kappa is expressed in Simon per centimeter. Both you can remember, Simon per meter, and often it is also measured in Simon per centimeter. Means per meter also, per centimeter also. Simon per meter, Simon per centimeter. This is the unit of conductivity. Question is asked. Okay. conductivity of a material conductivity of a material in Simon per meter is the conductance. This actually conductivity is the conductance. Okay, per meter only you are measuring, that is the difference. Conductivity of a material in Simon per meter is the conductance when it is 1 meter long and its area of cross section is 1 meter square. Area of cross section is 1 meter square and length you have to multiply. Simple. Okay. Then this conductivity of a material in Simon per meter is the conductance when it is 1 meter long and its area of cross section is 1 meter square. Here you should note that one Simons per centimeter, 1 Simon per centimeter is equal to 100 Simon per meter. Very clearly. That it is also related. 1 Simon per centimeter, that is equal to 100 Simon per meter, because both are related by 100, meter and centimeter. Okay. Then this I have told you about the, you can say, this conductivity, conductance and conductivity I have discussed. Now I am telling more about this. Okay. Here you can say that R can not like this thing. Other things I will tell you that now this things conductivity of different materials have different value. Conductivity you can say for different materials have different value, different solution have different value. Okay, conductors, different conductors also have different value. Conductors, then you know many conductors are there, semiconductors are there, only conductor you are telling. Then every conductor has a different value. As for example, copper, silver, gold, these are the conductors. Graphite, insulators. But insulator, you know that insulator, semiconductor, insulator, it will not allow to pass the current. That is the insulator. Semiconductor, you know, already discussed, it will pass. 50% like that you can tell, it will allow to pass, but not fully. And this conductors, it will allow to pass the current, but also it will differ, it will vary from conductor to conductor. Then three materials are there, that is you can tell insulator, semiconductor and conductor. Okay. Then this I have given example. And sodium, that is in solution I am talking about. Sodium, copper, silver, gold, iron, graphite. I am telling you it's this thing, conductivity. Sodium conductivity is 2.1 into 10 to the power 3. Correct? Sodium. Copper is more, 5.9 into 10 to the power 3. Okay, that is in meter, Simon per meter. Like that way, silver is 6.2 into 10 to the power 3. Gold 4.5, more than silver. Okay. Iron is less, 1.0 only into 10 to the power 3. Graphite little more, 1.2. Okay, now this graphite is more, 1.2 into 10 is high, and this glass is very less, 1 into 10 to the power minus 10. Teflon again further less, 1.0 into 10 to the power minus 18. Okay, and aqueous water I am talking about, it is 3.5 into 10 to the power minus 5, very less. Like that way, many, I can say, solution also conducts electricity and solid also conducts electricity, different type of solids. Okay, here solution conducts electricity, that is important things, NaCl, KCl, that also depends upon the concentration, how much concentration is there. According to that, it will conduct. Okay, conduction depends upon, conductivity depends upon the concentration, also can tell molarity. Then now here I am telling you little more that this things, this magnitude magnitude of conductivity varies a great deal and depends on the nature of material. It also depends on the temperature and pressure. This is important things. It also, this conductivity depends upon depends on this temperature and pressure at which the measurement is made. Materials are classified into conductance, into conductor, insulator and semiconductors depending on the magnitude of their conductivity. Metals and their alloys, metals and their alloys have very large conductivity and known as conductors. Okay, metals and their alloy mixture have very large conductivity and are known as conductors. Certain non-metals like carbon black, graphite and some organic polymers are also electronically conductive, okay, or you can say conducting substances. These carbon black, these are the actually non-metals like carbon black, graphite and some organic polymers are also electronically conductive substance, or they are conducting current. Substances like glass and these things, substances like glass, ceramic are having very high, having very low conduction or conductivity are known as insulator. Glass, ceramic, etc. have very low conductivity and known as insulator. Substances like silicon, doped silicon, gallium, arsenic having conductivity between conductors and insulators. Okay, between conductors and insulators, and are called semiconductors and are important electrical, you can say, materials. Certain materials called superconductors. Superconductor is very important. When R will be equal to 0, means no resistant substance having no resistance is called superconductors. and you can say this conductance superconductors, and conductivity is called superconductivities. R is equal to 0. That substance is very, very less. Okay, this is very, very important term I told you. Certain materials called superconductors by definitions have zero resistivity, zero resistance, or you can tell infinite conductivity. When resistance is 0, conductivity will be very high. Conductance will be very high. 0 resistance, then conductivity will be very high. Conductance will be very high. When resistance is 0, then that substance is called superconductor, having a very high conductivity. Okay, superconductors have very high conductivity. Material is called superconductor. Then this I have told about the this things superconductor, and actually superconductors where that compound is very less, that material is very less. Earlier only metals and their alloys were alloys at very low temperature, between the 0 to 15 Kelvin. Between 0 to 15 Kelvin were known to behave as superconductors at very low temperature. But nowadays a number of, you can say, substances are there. Number of, you can say, ceramic materials are you can say mixed. Actually ceramic materials and you can say other mixed oxides are available, are also known as, you can say, these things superconductor means ceramic number of many you can say ceramic materials, or you can say mixed oxides, they are also known as, you can say, superconductor. They show superconductivity at temperature, but temperature is now at little high, around 150 Kelvin. In the beginning I told you temperature was at very low temperature, it was showing between 0 to 15 Kelvin, but now it is showing superconductivity as high as 150 Kelvin. Okay. Now other things I want to tell you, that electrical conductance through metal is called metallic or electronic conductance. Electrical conductance through metals is called metallic or electronic conductance, and is due to the movement of electron. The electronic conductance depends on three major factors are there. Electronic conductance depends upon three major factors. What are that things? Then first, I am talking about the conductor. Okay. Electrical conductors. Okay. Through metals I am talking about, regarding metal, not regarding solution, metal. Then first factor is that the nature and structure of the metal. First factor, nature and structure of the metal. Second, the number of valence electrons per atom. This is the second. The number of valence electrons per atom. Because only electrons from the valence atom, only they will move, not inside. Only you can say valence electron, outermost orbit. Only from that electron can go outside. Third, temperature. It depends upon temperature. Actually, it decreases with increase of temperature. This you remember. Third factor is temperature. Then here decrease means conductance, electrical conductance decreases. It decreases with increase of temperature. Question is asked. Then these three factors I have discussed related to metallic conductance. Okay. As the electron as the electrons enter at one end and go out through the other end, the composition of the metallic conductor remains unchanged. This is again important point here. As the electrons enter at one end and go out through the other end, the composition of the magnetic conductor, the composition of the metallic conductor remains unchanged. That structure will not change. Composition of the metallic conductor will be unchanged, means will remain unchanged. The mechanism of conductance through semiconductors is more complex. It is very difficult to tell directly. You can't tell. Okay, how does it function? It is not in a straight way. I told you that if temperature will decrease, this I told you this temperature effect, it depends upon the temperature. Then conductance or conductivity, you can say, decreases with increase of temperature. Decreases. Then due to this mechanism, it happens. Now I want to tell you that this liquid, I am coming a solution. Now I am going to talk for the solution. That even very pure water has a small amount of hydrogen and oxygen, H2O. It dissociates as H plus OH minus. It dissociates, but dissociation is very, very less. Generally, it will not dissociate. It will in the form of H2O only. Maximum, very less will break into H plus and OH ion, and its conductance will be less, conductivity will be less. Then pure water has a small amounts of hydrogen and hydroxide ion, and means its concentration is 10 to the power minus 7 m. You know, pH value is 7. Then concentration will be concentration of H ion is equal to concentration of OH ion, and that is equal to 10 to the power minus 7 m molarity. Okay, which is this I told you these things. A small amount of hydrogen and hydroxyl ions are there, which actually lend it very low conductivity. Due to this, its conductivity will be very, very less. That is the 3.5 into 10 to the power minus 5 Simon per meter. This value remember. Conductivity of water, pure water, that is 3.5 into 10 to the power minus 5 Simon per meter. When electrolytes are dissolved in water, now it is becoming solution. When electrolytes are dissolved in water, they furnish their own ions in the solution. Hence the conductivity also increases, because this salt, they will furnish ion, and ion has charge. That's why conductivity will increase. Okay, the conductance of electricity by ions present in the solution is called electrolytic or ionic conductivity. You remember, when electrolytes are dissolved in water, they furnish their own ions in the solution. Hence, its conductivity also increases. Now, definition I am telling you, the conductance of electricity. The conductance of electricity by ions present in the solution is called electrolytic or ionic conductance. The conductance of electricity by ions present in the solution is called electrolytic or ionic conductance. The conductivity of electrolytes, also called ionic. The conductivity of electrolytic or ionic solution depends on 5 factors are there. This is very, very important. These 5 factors are different from the metal. 3 factor was there, that it was depending upon the nature and structure of the metal. Second, number of valence electrons per atom. And third, temperature. Now here in solution it is differing. Okay, there are 5 factors. You remember, question is asked in all examination. Then first factor means electrolytic, you can say conductance, or you can say ionic conductance or electrolytic conductance depends upon first the nature of electrolyte added. Means this salt added or substance added, what is their nature on that. Then first factor is nature of the electrolyte added. Second, size of ions produced and their solution. Means ions it will produce, then it is a big size, a small size, on that it depends. Size of the ions produced and their solution, because these ions will attract water molecules. Water molecules it will attract, that is called solution. It will attraction will be there. Then just like they will be associated with a very, very weak bond. Then on that size of the ion, because if size is small, it will move fast. If size is big, it will move slow. Just like a lean and thin person can run fast and 30% will run slow. Same situation is here. Third factor, that is the nature of the solvent and viscosity. Solvent and viscosity. What is the nature of solvent? Just you can understand like that. On road, if it is a pitched road, and then smoothly you are driving the motorcycle or any vehicles and going. But suppose if it is somewhat wet, WET, viscous like that, means suppose a newly road is formed recently, newly made road, pitch is there. Pitch is just recently, suppose 2 days, 3 days actually happened, then coal tar they have put on the road, Then that time, if you will drive the motorcycle, then you will find some resistance, because coal tar is now just recently put on the road, newly road. Then your motorcycle speed will be little less in comparison to that when it will full dry, then that time speed will be more, because that time resistance will be less. But in this situation, speed will be less because resistance is increasing due to liquid coal tar, just somewhat, it is not dried completely. Then that type of situation is there. Then third factor I was telling you, nature of the solvent and its viscosity, viscous. Okay, just like a gum is viscous, correct? GUM, viscous. Like that way, you can say it depends upon the viscosity and nature of solvent. Then here solvent, you know that many solvents are there, just water, pure water, and that is the main universal solvent. Other solvent, organic, benzene, carbon tetrachloride, CCl4, many organic compounds are there, ethane, methane. Then every solvent has their own nature. Then it depends upon solvent also, because solvents are molecules, as for example water, then it is H and OH ion. Then H and OH ion both are, H ion is positive charge, OH ion is negative charge. Hence, if you will add salt, then their ion also have a charge, negative and positive. Then they will attract oppositely, negative to positive, positive to negative, it will be attracted. That's why it depends upon the nature of solvent. Fourth point, that is the, you can say, concentration of the electrolyte. If more electrolytes you are adding, it means more ions it will produce. Cation and anions will be more. Then they will conduct more charge, more electricity. It will conduct more electricity. Okay, conductivity will be more because charges are more. Then if the concentration is more, mole per liter, mole per liter. Then if moles are more, number of moles are more, conductivity will be more. And last point, that is the temperature. Here situation is different. With increase of temperature, or it increases with increase of temperature. In the metal it was decreasing, but here it will increase with increase of temperature. But there it was decreasing with increase of temperature. Question is asked. Then fifth point, here I am telling you temperature. It depends on temperature, means it increases with increase of temperature. Okay. Then passage of direct current through ionic solution over a prolonged period can lead to change in its composition due to electrochemical reaction. Again, here important point, this you understand. Factors already discussed. Now little more I am talking, because again other discussions are there. Then passage of direct current through ionic solution over a prolonged period can lead to change in its composition due to the electrochemical reaction. Okay. Then here if reaction will take place, if reaction takes place in the solution, the new product will be formed. That's why at that time conductivity may change, composition will change. Then if composition will change, then this reactivity also can change, conductivity also can change. And today I am stopping only here. Next class I will discuss measurement of conductivity of ionic solution. Thank you.